Hello students, so this video is all about our second scope or unit, which was conservation of momentum. So in order to be successful on this section, which is going to be your second section of the final, we have some success criteria here. The goal was that you could identify and explain how momentum is conserved in multiple types of collisions. So you'll need to be able to identify momentum and factors that affect it, like mass and velocity, identify if a collision is elastic or inelastic, identify if a system is open or closed, and the last part is explain why momentum is conserved even when there might be changes in the speeds of the objects of the system. So here on the screen, you see two types of collisions. Before we start talking about which collision is which and all of that, to review, we know that the goal is for momentum to be conserved because the law of conservation of momentum tells us that a momentum should always be conserved. That means that the total momentum before a collision is equal to the total momentum after. So you take the momentum of one object and the momentum of the other one, and you combine them and you get the initial momentum, and then after you do the same thing, and they should be equal to each other. So we sometimes write it like this, that sigma means the sum of the initial momentum is equal to the sum of the final momentums for each object. So this is the law of conservation of momentum, that momentum is conserved in a collision when it's the same before and after. So no matter what happens in that collision, momentum is conserved if it's the same before and after. Because momentum is related to the mass and the velocity, so we can calculate momentum using this formula. P for momentum equals m times v, which is mass times velocity. So if we know the mass of the objects and we know how fast they're going, then we can tell how much momentum they have. And the same thing is true after the collision. If we know the mass of each object after the collision and we know how fast they're going, then we can calculate after. Now, here's the thing. In a closed system, momentum will always be conserved. So you can think about it either as one of two things, one of two ways. Either in our closed system, it tells us it's a closed system, so we know momentum should be conserved, or the other way around. If momentum is being conserved, then you can also tell it is a closed system. So those two concepts go hand in hand. Now, there are many different types of collisions out there, and we've simplified it down to two. We have elastic collisions, where the objects hit and bounce off of each other, and we have inelastic, where they hit and stick together. Both of these can be happening in closed systems. Both of these can be happening and make momentum be conserved. So we can actually see in different collisions momentum being conserved. So for example, in this elastic collision, notice that the velocity to the right for the green ball, it switches and gives that velocity to the pink one after. And the pink ball switches velocity with the green ball after the collision. So we have here that before, their masses are going to stay the same because mass is going to be conserved here as well. And so what happens is they change velocities, they trade velocities. So because this object's velocity has decreased and this object's velocity has increased, we see that trade-off where the one object now is going faster, the other object is going slower, and so there's that trade-off, that same velocity, even though they have switched. In an inelastic collision, you can tell it's inelastic based on that hit and stick, but also at the end, notice we only have one velocity here. There's the velocity starting out of the green ball, there's the velocity starting out of the red ball, but after an inelastic collision, a hit and stick kind of a collision, they've stuck together. So they now have become one mass. See how it says to add them together, and they have one final velocity. So same velocity at the end, which is v with the little f. And we have here for elastic different final velocities. So different final velocities. So in this unit, that's kind of the main points that we studied, but focusing on the fact that momentum is going to be conserved because it's going to be the same before and after a collision. Thanks for watching.